Good everyone. Today, like in our last class, we were discussing the quadratic root, and we only treated this question. We only treated this question. So now in today's video, we'll be treating other questions. So we'll know how to apply and how to approach whenever we are given this kind of questions. So now we said the question is if the root of the equation 3x squared plus 2x minus 1 equals to 0 are alpha and where alpha are alpha and beta. Now find alpha squared plus beta squared, which we found in our last class, whereby we discussed the final formula for alpha squared and beta squared plus beta squared, which is equal to alpha plus beta whole squared minus 2 alpha beta. So now today we shall be dealing with B, C, and D. So now let's start. Solution. Now for B, we have alpha all over beta plus beta all over alpha. Now how do we get all this? Now mind you, the goal of any question in this form is that make sure you deduce whatever you are given as your question to alpha plus beta and alpha beta. So which I explained in our last video. So meaning that the goal that as we have alpha over beta plus b all over alpha, we have to deduce this thing until they are in terms of alpha plus beta and alpha beta. So now let's try. Now whenever two fractions are combined, whenever a fraction and any other number, whether the two fractions are combined by what? Addition or subtraction, what do we find? We find the LCM. So what is the LCM of this question here? The LCM here is alpha beta. So alpha divided by beta, we have alpha. Alpha times alpha, we have alpha squared plus alpha divided by alpha is beta. Beta times beta is just beta squared. Now we got alpha squared plus beta squared all over alpha beta. Now mind you, we've gotten this in terms of alpha plus alpha beta, that's the denominator. But the numerator is too complex. Now, since we already know what our alpha squared plus beta squared is in the A, we can just substitute it by saying, recall that alpha squared plus beta squared is equal to alpha plus beta whole square minus 2 alpha beta. This is resolved in our last video. You can check out to know how we arrive at this. So now then substitute it. Substitute into, let's liberate the equation. Let's make this equation 1 and equation 2. So substitute equation 2 into, rather this is equation 1, equation 2 into equation 1. So now what's equation 1? Alpha squared plus beta squared all over alpha beta. So if we substitute it, we'll be having alpha plus beta, isn't it? All square minus 2 alpha beta all over alpha beta. Now let's check. Alpha plus beta is alpha beta, meaning we are 2. It is now in terms of alpha plus beta and alpha beta. So guess says it. So we can just say therefore our question alpha over beta plus beta over alpha is equal to this, which is what? Alpha plus beta all square minus 2 alpha beta all over alpha beta. So now we can substitute. So now recall that alpha plus beta is equal to minus b over a, and my alpha beta is equal to b over a, right? So I can now substitute by saying, alpha over beta plus beta over alpha is equal to minus b over a all squared minus 2 alpha beta is b over a, c over a rather. We've done this in our previous video, you can check it out. All over alpha beta is still c over a. You can see is equal to minus b squared is still b squared over a squared, isn't it? Minus 2c over a, right? All of this divided by c over a. So I have equals to, the LCM here is still a squared, right? So I have b squared minus 2ac, isn't it? All of this times this will invert a over c. So if we multiply it, I'll be having ab squared minus 2a squared c all over a squared c. All over a squared c. I can still factorize. A is common, go to the numerator and denominator. I can say a into bracket b squared minus 2ac all over a into bracket ac. Isn't it? So if a removes a, definitely I'll be having my alpha over beta plus beta over alpha equals to b squared over 2ac all over ac. Here is it. Here is the formula. So what is left for us to solve the question is just to substitute our ABC we have in the question. So we can do that. Let's just do that here. Okay. So now, since we've arrived at that, we can now say alpha over beta plus beta over alpha is equal to what's my b? Okay. From the question. From the equation 3x squared plus 2x minus 1 equals to 0. A is equal to 3, b equals to 2, and c is equal to minus 1, right? C is equal to minus 1. I will just say my alpha over beta plus my beta over alpha is equal to my b, 2 squared minus 2 times a is 3 times what's my c? Minus 1, right? All over a, 3 times minus 1, so which is equal to 4 minus, okay, minus times minus will become plus, 2 times 3 is 6 times 1, still 6, all over 3 times minus 1, minus 3, so I'll be having minus 10 over 3, which is equal to alpha over beta plus beta over alpha. Quite easy though, so that's just it, minus 10 over 3. So that's that about the question 2. So now moving to the third aspect of it. So I hope this is clear. Now let's go to the third aspect of our question. So you have to know all these formulas offhand. Okay, now for the third one, minus c, we have alpha cube plus beta cube, right? So now, looking at this question, we are asked to look for this and we have to deduce it in terms of alpha plus beta and alpha beta. The question is, how do I know what to do next? The point is this: for you to have any perfect cube, definitely you must have expanded the binomial of the power of 3. Like what I said in my last video when I was trying to prove this out. Same thing. So the perfect cubes are found whenever you expand a perfect a binomial with the power of 3. So now applying to this, I can say I'm aware that this is not equal to alpha plus beta all cubed. They are not equal. But this is a binomial with the power of 3. In which if I should solve this, I will find these two things within. So let me break this down to extract this. So okay, now alpha plus beta all cubed will be equal to what? Alpha plus beta, right? Alpha plus beta, right? Alpha plus beta. I'm not rushing. I want to open it one after the other. So now this because after alpha times alpha, I'll be having alpha squared plus alpha times beta, alpha beta, beta times alpha, alpha beta, beta times beta, beta squared. Now times this. I like you to follow me diligently. Okay. So let me open the next one. Alpha squared plus alpha. I have alpha cube. I have alpha cube, right? Now this same thing times beta. Alpha squared beta. Now let's go to the next one. Alpha beta times this. I have alpha squared beta. Alpha this times this, I have plus alpha beta squared. Second one, alpha beta times alpha, I have alpha squared beta. Alpha beta times beta, I have alpha beta squared. Now, next one, beta squared times alpha, I have alpha beta squared. beta squared plus beta times beta squared, I have beta cube. So let's bring correct items. So I can have, okay, when alpha is cube, it's just once, it only occurred once. When alpha is squared, I have this alpha squared beta, next one, right? Plus alpha squared beta. Do you have another one? Yes, plus alpha squared beta. Okay, now when beta is now squared, equal plus alpha beta squared, right? Plus here alpha beta squared plus here alpha beta squared. Do we have another one? Okay, beta cube just once. So now I can now say alpha cube equals to 1, 2, 3. A mango plus another mango plus another mango to give me was 3 mangoes. Plus 3 mangoes. What's that our mango? Is 3 is alpha squared beta. Just like a plus a plus a, 3. Same thing I've applied here. So plus same thing applies to this. 3 alpha beta squared now plus beta cube. So let me now, okay, alpha cube plus beta cube plus 3. What's common here? Okay, 3 alpha beta is common here, right? Okay, into bracket. What will be left here? Alpha will be left here, then beta will be left here. Now what we've just gotten is equal to alpha plus beta of cube. Now look at it carefully. You will find out I've got what I'm looking for, which is this. Okay, in order to make it, this is what I'm looking for. So the point is now I'm just to make it a sort of formula now. So to make it a sort of formula, what I just need to do is transfer every other thing to the other side. So I can now have this alone on one side, alpha cube plus beta cube equals to, what was here? Alpha plus beta all cube. If this comes here, it becomes minus 3 alpha beta into bracket alpha plus beta. So now looking at this, I'm asked to deduce this, right? Which is this C. Now it's now in terms of alpha plus beta in bracket. Alpha plus beta. Meaning it is done. So this is now just the formula. So now let me break it down so I can just solve the question above. So I can now say, okay, alpha cube plus beta cube is equals to alpha plus beta is what? Minus b over a all cube, right? Then minus 3 alpha beta is c over a. Alpha beta is minus b over a, isn't it? So I can say is equal to negative b cube is still equal to negative b cube. Yes, because minus times minus is plus, plus times minus is return to minus again. So over a cube minus, okay, minus times minus will be plus. So 3 times c times b, 3bc all over what? A squared. The LCM here is a cube. So a cube and a cube is just 1. So I have minus b cube plus a cube divided by a squared is a. So we're having 3abc. So to make it balanced, so I can say my alpha cube plus beta cube is equal to, let me bring this first, right? So I can have 3abc minus b cube all over a cube. So this is the formula I'm applying now to solve my question. So from my question, my a is equal to 3, my b is equal to 2, and my c is equal to minus 1. So now alpha cube plus beta cube will then be equal to 3 times a, 3 times b is what? 2, c is what? Minus 1, right? Minus b is 2 cube. I hope this is clear. So okay, all over a is what? 3 cube also. So my alpha cube plus my beta cube, 3 times 3, 9 times 2, 18 times minus 1 is minus 18 minus 2 raised to power 3 is 2 times 2 times 2, which is equal to 8. Now 3 times 3 times 3 is what? 27. So now my alpha cube plus my beta cube will then be equal to minus 18 minus 8 is equal to minus 26 all over 27. That's the final answer. So it's as simple as that. So we are done with this. It's as simple as the goal is just find a way. Though the point is just deducing whatever you are given to find, to make sure they are in terms of alpha plus beta and alpha beta. And whenever it is in this form, always please in mind that for you to have a perfect cube, two perfect cubes, it is simply what the what is it called, the expansion of the binomial with the power of 3. If it is sum of two fourth powers, same thing this one too before, like that. And also if it is difference of two squares, you now apply that difference of two cubes, like that. But I'll be doing this, then after that we'll be rounding up for today's class. So that's that about the C. So and lastly, for the D, we are told to find the alpha. Okay, we are told to find my alphas minus beta. We know alpha plus beta is equal to minus b over a. Which one is alpha? And mind you, in regarding my alpha squared plus my beta, okay, beta still, let me just write it beside it. This is equal to alpha plus beta all square minus 2 alpha beta. Then for this is equal to alpha plus beta all square minus 2 alpha beta all over alpha beta. Then for this it is equal to alpha plus beta all cube, which is minus 3 alpha beta 2 brackets alpha plus beta. So now we have to do this, which we don't know yet. So when we know, we fill it in. When we know, we fill it in. So now the last one, alpha minus beta. The question is, how can I think? How can I make this equal to something? How can I deduce this into alpha plus beta and alpha beta? Now the question is this: any number. When I treated a topic one time, which is factorization, by way of equation, then I gave an assignment. I said factorize s squared minus 7. You'll be wondering, how will I factorize this? Because 7 is not a perfect square. So how do I factorize it? 7 can be made a perfect square, even though it's not a perfect square, because 7 is still equals to root 7 squared. I've made it a perfect square like this. Same thing we are applying it. This thing is more or less like a prime factor, a prime number. You get it? So how do you make it a perfect square? You make it a perfect square by applying the same thing. By applying what? The same thing. As simple as that. So now I have the hope of expanding here, do some other stuff here. So now I can have, from there I can say this is equal to square root of alpha minus beta, right? Alpha minus beta. Isn't it? So now equals to square root of alpha squared minus alpha beta plus beta squared. Isn't it? So now I can now equals to square root of alpha squared plus beta squared minus what? 2 alpha beta. I've gotten this in terms of alpha beta. It's left with this. And alpha squared plus beta squared, we've done that here. So just substitute it. So equals to square root of alpha squared is equal to what? Alpha plus beta. I'm doing this now. Okay, now alpha plus beta all square minus 2 alpha beta. Now the original minus 2 alpha beta that was here. So equals to square root of alpha plus beta all square minus 2 alpha beta minus 2 alpha beta equals to what? Minus 4 alpha beta. And this thing here is equal to alpha minus beta. Do you get it or not? Got it. Now this thing is now in terms of alpha plus beta and alpha beta. As simple as that. So same thing here, if you are given this kind of question, you'll be like, how do I make this a perfect square? Same thing happened here, and it happened. We made it a perfect square. So actually, I can apply something by saying this thing is equal to square root of 7 squared is 49. 49 is still 7. Meaning what we applied here is not longer, it's correct. I applied it here. And as well as I can say this cancel this. Still giving me the same 7. So that's the point. I hope that is clear. So that's that about that. So let's deduce it to, and let's deduce it in terms of A, B, and C. So I can say my alpha minus beta is equal to square root of alpha plus beta is minus b over a all squared minus 4. Alpha beta is c over a. So I can say my alpha minus beta is equal to square root of minus b squared is b squared over a squared minus 4c over a, right? So my alpha minus beta is equal to square root of, LCM here is a squared, right? So I have b squared left here minus 4ac. So applying surd law by splitting the root, b squared minus 4ac all over square root of a squared. So this square cancel this one. So I'll be left with this root b squared minus 4ac all over a. All over a. So from here I can easily, anywhere I see b, I insert my values according to the equation in the question. So let's just do that to finalize our solution. Okay, since we've gotten that, so I can say my alpha. Okay, now from the equation, from the equation 3x squared plus 2x minus 1 equals to 0. A equals 3, b equals 2, and c equals to minus 1. So I can say minus a alpha minus beta is equal to square root of b squared is 2 squared minus 4 times 3 times c is minus 1, right? All over a, which is 3. So my alpha minus beta square root of 2 squared is 4, minus times minus becomes plus. 4 times 3 is 12, times 1 is still 12, all over 3. So my alpha minus beta is equal to square root of what? 16, right? All over 3. Alpha minus beta equals to 4 over 3. That's the value for this. So the formula we applied here is that this thing here is equal to square root of alpha plus beta all square minus 4 and 4 beta. So that's that about this. It was the quadratic root. So finally we are done with this. So I hope you understand. Quite alright. Okay, so in our next class we will be treating indices and logarithm. And don't forget to subscribe to this channel. Comment below your views, your point of your perspective about this channel, about the classes we upload there. So you can tell us your point of view, what you feel like, what you need and we've not done. So just drop it in the comments below. Don't forget to like, share, also subscribe to our channel. So thanks for watching. Thank you very much. My name remains Ajala Peter. Meet you in our next class.